Imagine, right now, somewhere far beyond Neptune, there might be a giant planet hiding in the shadows, quietly orbiting the Sun. A planet so elusive, it has never been seen directly by any telescope. This is the mystery of Planet 9, a hidden world that could completely change everything we thought we knew about our solar system. Why does this matter? Because if Planet 9 really exists, it would rewrite the textbooks. It would challenge our entire understanding of how the solar system formed and evolved. It might explain strange patterns in the orbits of icy objects at the edge of our cosmic neighborhood, patterns that just don't make sense without something big out there pulling the strings. But how did we come to suspect that this hidden planet exists at all? The story is as thrilling as any space mystery, starting with puzzling orbits, strange gravitational effects, and the patient detective work of astronomers piecing together clues from the farthest reaches of the solar system. What exactly are these clues, and could they truly lead us to a new planet? Or is Planet 9 just an illusion, a cosmic ghost we're chasing in the dark? The answers might change the way we see the solar system forever. When you think about our solar system, you probably picture the 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, orbiting the Sun in neat, predictable paths. But beyond the familiar planets lies a far stranger, more mysterious place. A realm so distant and cold it's filled with countless icy rocks and dwarf worlds that barely reflect the Sun's faint light. This is the Kuiper Belt, a vast frozen frontier at the edge of our cosmic neighborhood. What exactly is the Kuiper Belt? The Kuiper Belt is a ring of small, icy bodies that extends roughly from 30 to 55 astronomical units from the Sun. One astronomical unit being the average distance from Earth to the Sun, about 93 million miles. To put it simply, the Kuiper Belt is a giant donut-shaped zone beyond Neptune, where thousands, possibly millions, of frozen objects orbit quietly in the darkness. Scientists often call it the third zone of the solar system. The first zone includes the rocky inner planets. The second zone holds the gas giants like Jupiter and Saturn. And the third zone, the Kuiper Belt, is home to a frozen graveyard of ancient leftovers from the solar system's birth. You know, this distant region was purely theoretical for decades. Even the existence of Pluto, discovered in 1930, was a surprise to astronomers at the time. For years, Pluto was considered the 9th planet, the outermost sentinel of the Sun's family. But then, in the 1990s, the Kuiper Belt itself was discovered, and with it came an astonishing revelation. Pluto was just one of many similar objects. This discovery changed everything. Suddenly Pluto wasn't unique. It was part of a whole population of icy bodies orbiting in the cold, dark outskirts of the solar system. Some were almost as big as Pluto, others were small rocks barely a few kilometers across. But what united them was their location, a vast, distant swarm stretching out beyond Neptune's orbit. The Kuiper Belt hosts a menagerie of strange worlds. Some, like Eris, Haumea, and Makemake, are called dwarf planets because they're large enough to be roughly spherical but haven't cleared their orbits of other debris. Many other objects are tiny fragments of ice and rock, cosmic leftovers that never became full-fledged planets. Scientists have spent decades mapping this icy belt, trying to understand its composition, history, and what it can tell us about the solar system's early days. Studying Kuiper Belt objects, or KBOs, is like peering back in time. These frozen relics have remained largely unchanged for billions of years, preserving clues about the building blocks that formed the planets we know today. But while most of these distant objects orbit the Sun in random, scattered paths, some of them behave strangely. In the 2000s, astronomers began noticing something odd about the orbits of several Kuiper Belt objects. Instead of wandering independently like isolated travelers, a group of these icy bodies seemed to share an unusual alignment in their orbits. Their paths were not only elongated, meaning they stretched far out from the Sun, but their orbits were strangely clustered, pointing in roughly the same direction. This was unexpected. Without any massive object influencing them, You would expect these orbits to be randomly oriented over billions of years, slowly drifting and scattering. Instead, they seem to be locked in a pattern, as if pulled and pushed by the gravitational grip of something far away. Astronomers were puzzled. What could cause this cosmic choreography at the edge of the solar system? Some theories suggested that perhaps a large number of small objects collectively created this effect, but the numbers just didn't add up. Other ideas involved distant stars passing by in the past or unknown forces acting on these objects. But the simplest and most striking explanation was that a massive planet, much bigger than Earth but still unseen, was lurking out there, shepherding these icy bodies with its gravity. This mysterious planet, dubbed Planet 9 or sometimes Planet X, became the hottest topic in astronomy circles. The idea of a hidden giant planet beyond Neptune isn't entirely new. Astronomers have long speculated about unknown worlds beyond the known planets, especially when strange orbital patterns were noticed in the past. But it wasn't until 2016 that astronomers Konstantin and Mike Brown at Caltech published a groundbreaking study bringing scientific weight to the Planet 9 hypothesis. By carefully analyzing the orbits of 6 distant Kuiper Belt objects, they showed that the clustering of their orbits was statistically unlikely to be a coincidence. Using computer models, they demonstrated that a massive planet, estimated to be about 5 to 10 times the mass of Earth, orbiting far beyond Neptune could explain these mysterious patterns perfectly. This new planet wouldn't be like the gas giants closer to the Sun. It would be a cold, dark world, orbiting at hundreds of astronomical units away, roughly 20 times farther from the Sun than Neptune is. Because it's so far and faint, even the most powerful telescopes haven't been able to spot it directly yet. But the evidence was compelling. If Planet 9 exists, it would really reshape how we understand the solar system. It would mean that our planetary family has been hiding a giant member in the shadows all along, a world we've only just begun to discover. This could explain not only the strange orbits of Kuiper Belt objects, but also answer deeper questions about how the solar system formed and evolved. For example, Planet 9 might have influenced the movements of other distant objects, or even played a role in shaping the orbits of the inner planets long ago. But there's more. The discovery of Planet 9 would spark a new era of exploration, inspiring scientists and the public alike to look deeper into the farthest reaches of space. It might even offer clues about the formation of planets around other stars, since, many exoplanet systems include planets far from their suns, just like Planet 9 would be. The search is on, but why is it so hard to find? Finding Planet 9 is no easy task. Its extreme distance means it reflects very little sunlight, making it incredibly faint even for giant telescopes. It moves very slowly across the sky, and the vast area it could be hiding in makes the search like looking for a needle in a cosmic haystack. Astronomers are using cutting-edge telescopes, advanced sky surveys, and clever algorithms to scan the skies, hoping to catch a glimpse of this hidden world. Every discovery of a new Kuiper Belt object sharpens the search, narrowing down where Planet 9 could be. Yet despite years of searching, it remains elusive. Could Planet 9 be something else? Some scientists remain skeptical. They point out that while the clustering of orbits is intriguing, it might be explained by other phenomena, such as observational bias or interactions among smaller objects. Others suggest the possibility of multiple smaller bodies instead of a single giant planet. But the mystery remains open, fueling debate and curiosity. What exactly is pulling the strings at the edge of our solar system? Is Planet 9 a massive hidden world, or a cosmic illusion shaped by chance and incomplete data? Could there be something even stranger lurking in the darkness? The answers to these questions will reshape our understanding of the solar system, but for now, the mystery remains unsolved, inviting us to look up, wonder, and keep searching. If the Kuiper Belt is this vast, icy frontier far beyond Neptune, Then what exactly made astronomers suspect that a giant planet might be hiding there? The answer lies in a strange pattern, an invisible thread tying together some of the most distant and mysterious objects orbiting the Sun. It starts with the peculiar clustering of Kuiper Belt objects, or KBOs. When astronomers began tracking the orbits of these icy bodies, they noticed something astonishing. Instead of being scattered randomly across the outer solar system, several KBOs seemed to share a strange alignment. Their orbits weren't just elongated and eccentric, they were clustered tightly together in space, pointing in roughly the same direction. Imagine tossing a handful of marbles onto a table and seeing most of them rolling into neat lines or groups instead of spreading out randomly. That's how unusual this orbital pattern is. It's like these objects are dancing to a cosmic tune played by an unseen conductor. Two of the most famous members of this mysterious club are Sedna and 2012 VP 113, objects so distant and peculiar that they almost seem like aliens among the solar system's residents. Sedna was discovered in 2003 and instantly grabbed attention. It's a massive, icy body with an orbit so elongated that it takes over 11,000 years just to complete one trip around the Sun. What's mind-blowing is that Sedna never comes close enough to Neptune's gravitational influence to explain its orbit. Something else is tugging on it. Then, in 2012, astronomers found 2012 VP 113, sometimes called Biden, after the discoverers jokingly named it. This object's orbit is similar to Sedna's, extremely distant and elongated, with its closest approach to the Sun still far beyond Neptune. These two strange objects seem to hint at a common cause, something massive and distant shaping their paths. So how do astronomers study these faint, slow-moving worlds so far away? The answer is a combination of observations and sophisticated computer modeling. Using powerful telescopes, scientists track the positions of these distant KBOs over time, mapping their orbits with incredible precision. But because these objects are so far and faint, direct observations alone aren't enough to reveal the big picture. That's where computer simulations come in. By inputting the known orbits and testing different gravitational influences, astronomers can simulate how these objects might have ended up in their current positions. If their orbits only make sense with the presence of a large, unseen planet exerting gravitational pull, that's a strong clue that Planet 9 could be real. The most pivotal moment came in 2016 when astronomers Konstantin Batygin and Mike Brown published their groundbreaking paper presenting this evidence to the world. Their study showed that a planet roughly 5 to 10 times the mass of Earth, orbiting hundreds of astronomical units away, could explain the clustered orbits of these distant KBOs perfectly. The reaction within the scientific community was electric. Some scientists embraced the idea with excitement, seeing it as a natural explanation for a long-standing mystery. Others remained cautious, emphasizing that more evidence was needed and that the hypothesis needed to be tested through observation. But the paper undeniably rekindled the search for new planets in our solar system and pushed astronomers to look deeper, using new telescopes and surveys to find Planet 9, or prove it doesn't exist. What other secrets could these distant icy worlds be hiding? And what would it mean for our understanding of the solar system if a giant planet has been silently shaping their orbits all along? Could we be on the brink of discovering a whole new member of our planetary family, or is this mysterious pattern a cosmic coincidence waiting to be explained differently? The quest to find Planet 9 has only just begun, and the clues are both tantalizing and puzzling. Section 3. What is Planet 9? So, what exactly is Planet 9? What kind of world do astronomers imagine is hiding in the cold depths beyond Neptune, and how does it compare to the planets we know? From the clues we have, the strange orbits of distant Kuiper Belt objects and the mathematical models, scientists have developed a hypothesis about Planet 9's characteristics. While no one has seen it yet, these educated guesses paint a fascinating picture: size and mass. Planet 9 is thought to be a giant, much bigger than Earth, but smaller than the gas giants like Jupiter or Saturn. Estimates suggest it could be about 5 to 10 times the mass of Earth, which places it in the category of a super-Earth, or a mini-Neptune. That means it could have a thick atmosphere of hydrogen and helium, or maybe a dense mix of ice and rock. It wouldn't be a blazing hot planet like Mercury, but a cold, distant world, bathed in the faint glow of the distant sun. Orbit. Its orbit is predicted to be huge and highly elongated, stretching hundreds of astronomical units away from the Sun. For context, Neptune orbits about 30 AU from the Sun, while Planet 9 might be anywhere from 400 to 800 AU at its farthest point. It would take anywhere from 10,000 to 20,000 years to complete just one orbit. Imagine a world so far out that its year is longer than the entire span of human civilization, an orbit so vast it slowly drifts through the farthest reaches of our solar system, almost beyond the grasp of our best telescopes. How Planet 9 differs from classical and dwarf planets. Unlike the classical planets, which mostly orbit in a relatively flat plane called the ecliptic and follow nearly circular paths, Planet 9's orbit is tilted and eccentric. It swoops in and out unlike anything else in the solar system. Also, it's much more massive than dwarf planets like Pluto or Eris, which are tiny in comparison. While dwarf planets are mostly icy bodies too small to clear their orbits, Planet 9 would dominate its region of space gravitationally, though it's still hidden far from the sun's warm light. The challenge of direct observation. Why haven't we seen Planet 9 yet? The answer is simple but frustrating. It's incredibly faint. Because it's so distant, the sunlight it reflects back to Earth is tiny, millions of times fainter than Neptune. This makes it almost invisible against the dark canvas of space. Even our most powerful telescopes have only surveyed parts of the sky where Planet 9 might be hiding. It moves very slowly, so spotting it requires patience and careful, repeated observations. It's a cosmic game of hide-and-seek, where the planet is both huge and tiny, distant and elusive. Comparison with known planets and exoplanets. Interestingly, Planet 9 might be more like some of the mysterious planets we've found orbiting other stars, super-Earths or mini-Neptunes that don't exist in our inner solar system but seem common elsewhere in the galaxy. Many exoplanet systems discovered by NASA's Kepler mission include planets several times the size of Earth, orbiting far from their stars. Planet 9 could be our solar system's missing link, a planet that formed differently or was knocked into a distant orbit long ago. If true, Planet 9 would show that our solar system is even more diverse and strange than we imagined. What secrets does Planet 9 hold? Could it be a frozen, lonely world with a mysterious past? And what can it tell us about how planets form and move both here and around distant stars? As astronomers continue to search the skies, the mystery deepens. How much more does the outer solar system have to surprise us? Section 4. The search so far. The hunt for Planet 9 is one of the most exciting and challenging quests in modern astronomy. But searching for a world so distant and faint isn't like spotting Venus shining brightly in the evening sky. It requires patience, powerful instruments, and a bit of cosmic detective work. One of the key tools in this search is the Subaru telescope, perched high atop Mauna Kea in Hawaii. With its enormous 8.2-meter mirror, Subaru is one of the most powerful telescopes in the world, capable of peering deep into the dark outskirts of our solar system. Astronomers have used Subaru and other large telescopes around the globe to scan vast areas of the sky, hunting for any faint, slow-moving object that might be Planet 9. The telescope takes repeated images of the same patch of sky, looking for tiny dots of light that shift position very gradually over days, weeks, or months. But this search is far from easy. First, Planet 9 is unimaginably far away, hundreds of times farther from the Sun than Earth. At such distances, sunlight is incredibly weak. That means Planet 9 reflects only a tiny fraction of light, making it extremely faint and difficult to spot against the blackness of space. Second, Planet 9 moves very slowly. The further an object is from the Sun, the slower it travels along its orbit. Unlike the fast-moving planets closer in, Planet 9 could take thousands of years to complete a single orbit. This slow movement means it might appear almost stationary during brief observation windows, making it tricky to distinguish from distant stars. Third, the sky is vast. Even with the most powerful telescopes, astronomers must carefully choose where to look based on models and clues. It's like searching for a faint firefly in a massive dark forest. The search is far from over. In fact, new instruments coming online soon promise to revolutionize our ability to find Planet 9. One of the most anticipated is the Vera C. Rubin Observatory in Chile. Set to begin operations soon, Rubin will conduct the Legacy Survey of Space and Time, LSST, mapping the entire visible sky deeply and repeatedly over 10 years. This massive survey will capture incredibly detailed images, capable of spotting faint, distant objects moving slowly across the sky, including possibly Planet 9. Meanwhile, the James Webb Space Telescope, JWST now operational, could provide valuable follow-up observations. While JWST's main focus is distant galaxies and exoplanets, Its powerful infrared capabilities might detect the faint heat emitted by a cold, distant planet that's invisible in visible light. Together, these telescopes could finally bring Planet 9 out of hiding. Computer simulations guiding the search astronomers don't just look blindly, they use powerful computer simulations to predict where Planet 9 is most likely to be found. By modeling the orbits of the clustered Kuiper Belt objects and simulating Planet 9's gravitational pull, they narrow down the regions of the sky where it should be lurking. These models are constantly updated as new KBOs are discovered and more data comes in. Every new discovery sharpens the search, shrinking the vast cosmic haystack into a smaller, more targeted area. Could the next observation finally reveal Planet 9's hidden face? Or will this elusive world continue to evade our gaze, deepening the mystery of the outer solar system? As technology advances and telescopes become more powerful, the greatest astronomical detective story of our time continues, inviting us all to watch, wait, and wonder. Section 5. Alternative Theories. While the idea of a hidden giant planet lurking beyond Neptune captures the imagination, scientists have also explored other more exotic possibilities for what might be causing the strange orbital patterns we observe. These alternative theories are as fascinating as they are mysterious, and sometimes downright mind-bending. Could it be a primordial black hole? One of the most dramatic alternatives is the idea that the mysterious Planet 9 isn't a planet at all, but a primordial black hole. Unlike the black holes formed from dying stars, primordial black holes could have formed in the early moments after the Big Bang, tiny, incredibly dense objects scattered through the galaxy. If such a black hole with a mass about 5 to 10 times that of Earth was drifting silently in our solar system's outer reaches, its gravity could explain the odd clustering of Kuiper Belt objects. What's mind-blowing is that, if true, this would be the first evidence of primordial black holes, providing clues about the earliest moments of the universe. But detecting a small black hole in the darkness is nearly impossible. It emits no light, only gravity, making it the ultimate cosmic ghost. Rogue planet capture theory. Another fascinating idea is that Planet 9 might be a rogue planet, a planet that didn't form in our solar system at all, but wandered through space, untethered to any star, before getting captured by the sun's gravity. Rogue planets are thought to be quite common in the galaxy, ejected from their original systems during chaotic early years. If Planet 9 is one of these cosmic drifters, it would explain why its orbit is so different from the classical planets. This theory suggests our solar system may be more like a cosmic neighborhood, occasionally picking up visitors along the way. But capturing and keeping a rogue planet on a stable, elongated orbit is tricky, and models suggest it would be a rare cosmic coincidence. Exotic ideas, alien megastructures, and dark matter clumps. The most speculative theories stretch even further into the realm of science fiction. Some have wondered if the mysterious gravity source could be an alien megastructure, a massive artificial object built by an advanced civilization, like a Dyson sphere or planet-sized machine. Others propose it might be a clump of dark matter, invisible material that makes up most of the universe's mass but doesn't interact with light. If dark matter forms dense clumps or halos, one could be lurking at the edge of our solar system, pulling on KBOs with its hidden gravity. While these ideas fire the imagination, they remain speculative and lack direct evidence. But they remind us how little we truly know about the cosmos, and how the universe might still surprise us. Why mainstream science is cautious. Mainstream scientists approach these alternative ideas with healthy skepticism. Science demands solid evidence and repeatable observations, not just exciting possibilities. The primordial black hole hypothesis, rogue planet capture, and exotic theories all require extraordinary proof that's simply not there yet. Until Planet 9 or its alternative is directly observed, these remain intriguing but unconfirmed ideas. That said, exploring these theories pushes the boundaries of our understanding, driving astronomers to develop new tools, refine models, and keep an open mind about what's out there. Could Planet 9 turn out to be something far stranger than a simple planet? Or will the truth be something even more extraordinary, hiding just beyond the reach of our instruments? The mystery deepens, inviting us to question not just what's out there, but how much we truly understand about our place in the cosmos. Section 6. Implications if Planet 9 is found. What if Planet 9 is finally found? How would the discovery of this hidden giant reshape everything we think we know about our solar system, and beyond? Reshaping solar system formation theories. For decades, astronomers have developed models explaining how our solar system formed. a swirling disk of gas and dust around the young sun, gradually coalescing into the planets we know today. But Planet 9 doesn't fit neatly into these traditional stories. Finding Planet 9 would force scientists to rethink how planets form and migrate. Was it born closer in and pushed out by gravitational interactions? Or did it form far away in a distant, cold region? Could it be a captured rogue planet? Each possibility challenges the neat, orderly picture of planetary formation and hints at a more chaotic, dynamic early solar system than we imagined. Effects on understanding comet paths and planetary tilts. Planet 9's gravity might also help explain some other long-standing mysteries closer to home. For example, why do some comets have such strange, elongated orbits? Could Planet 9 be nudging them, sending icy visitors hurtling toward the inner solar system? Even the tilt of Uranus, rotated on its side compared to other planets, might be linked to gravitational tugs from this unseen giant. Its presence could help explain quirks in the solar system's architecture that have puzzled scientists for years. The possibility of missions or probes in the future. Imagine this. Once Planet 9 is located, what if we could send a mission to visit it? It would be a daunting journey, thousands of times farther than Earth's distance to the Sun, but robotic probes could travel there over decades. A mission could reveal its atmosphere, composition, maybe even its moons, turning this distant enigma into a real world, with stories to tell. Already concepts for deep space probes are being discussed, combining new propulsion technologies with decades-long missions. The discovery of Planet 9 could become a catalyst for humanity's next giant leap into the outer solar system. Philosophical impact. Our place in the cosmos. Beyond science, the discovery of Planet 9 would also carry profound philosophical weight. It would remind us that even in our own cosmic backyard, there are still huge secrets waiting to be uncovered. A new planet would shift our perspective on how much we really know about the solar system we call home. Would it change how we see ourselves, not just as Earthlings, but as explorers in a vast mysterious universe? Could it inspire a new era of curiosity, humility, and wonder? What if Planet 9 turns out to be just the beginning? Could our solar system harbor even more hidden worlds? How would these discoveries transform not just science, but our view of ourselves and the grand cosmic story? The answers remain just out of reach, waiting for the next breakthrough, the next discovery, the next curious mind ready to explore. Section 7. What if it doesn't exist? What if after all this search, Planet 9 turns out to be a cosmic mirage, a planet that never actually existed? It's a possibility that scientists take seriously. Science isn't just about chasing mysteries, it's about testing ideas, questioning assumptions, and sometimes realizing we were mistaken. Other explanations for orbital anomalies. The strange clustering of distant objects in the Kuiper Belt might not be the gravitational signature of a hidden planet at all. Instead, some astronomers propose that the odd orbits could be explained by the combined gravitational influence of many smaller objects, perhaps a vast, unseen disk of icy bodies beyond Neptune. Or maybe the patterns arise from interactions with passing stars in the Sun's ancient neighborhood, or even from subtle effects caused by the galactic tide, gravity from the Milky Way itself. These alternative ideas suggest the solar system's outskirts are more complex and dynamic than a single planet's gravity. Could the data be biased or misinterpreted? Another important question is, how reliable are the data and observations? The outer solar system is a dark, distant, and sparsely populated place. Observing tiny, faint objects billions of miles away is incredibly challenging. Could the clustering of orbits be a statistical fluke, caused by limited observations or biases in how and where astronomers look? Some scientists argue that the sample size of known Kuiper Belt objects is still too small to draw firm conclusions. Others caution that observational biases, like searching only in certain parts of the sky, might create the illusion of patterns that aren't really there. What this means for future research: if Planet 9 doesn't exist, that doesn't mean the mystery is over. Instead, it opens new questions. What else shapes the outer solar system? How do small bodies interact over billions of years? And how can we improve our observations to find the real answers? It also means astronomers must keep looking and keep questioning. The search for Planet 9 has pushed technology, inspired new theories, and expanded our understanding of distant space, no matter the outcome. Could the true story be even stranger than a hidden planet? What if the solar system's outer frontier is shaped by forces we have yet to imagine? The absence of Planet 9 would be just as profound a discovery, challenging scientists to think bigger, look closer, and keep the curiosity alive. The cosmos is the ultimate crime scene, a vast expanse filled with mysteries waiting to be unraveled. Every twinkling star, every swirling galaxy, and every shadowy corner holds secrets that have challenged humanity for millennia. But the only crime here is the universe's relentless effort to hide its own secrets, tucking them away in the darkness, daring us to uncover them. For centuries we've been cosmic detectives, piecing together clues from the faintest glimmers of light, the subtle pull of gravity, and the passage of time itself. Our tools have evolved, but our curiosity remains unchanged. We look up and wonder, what are those lights scattered across the night sky? Are they distant suns, or something more? How far away are they? Could there be other worlds like ours? Are we truly alone in this immense universe, or is there life waiting to be discovered? This detective story has led to incredible discoveries, from the moons of Jupiter to galaxies billions of light-years away. Each breakthrough has only deepened the mystery, revealing new puzzles to solve. But now, a new and tantalizing mystery is unfolding, not in a distant galaxy, but right here in our own solar system. There's a disturbance, a subtle but persistent puzzle in the orbits of distant objects, suggesting we may have miscounted the planets that call our solar system home. Evidence is mounting for something massive, a true planet lurking unseen in the far reaches, its gravity shaping the orbits of icy worlds at the edge of our solar system. This is the story of Planet 9, a ghost in our cosmic machine, a hidden world that could change everything we know about our place in the universe. The search for Planet 9 is more than a cosmic scavenger hunt. It's a quest that could rewrite our understanding of the solar system, and perhaps even the origins of our own planet. Imagine a world 10 times Earth's mass, shrouded in darkness, hiding just beyond our view, waiting for the right moment to be found by those daring enough to look. We're about to journey to the darkest, coldest reaches of our solar system, following the faintest clues left by gravity and venturing into the unknown. The hunt for Planet 9 is on, and the greatest discoveries may still be hidden in plain sight, waiting for us to uncover the next chapter in the universe's great detective story. Our story begins far from the sun, in the icy darkness beyond Neptune, the Kuiper Belt. This vast, mysterious region is a frozen frontier, a cosmic graveyard of ancient objects left over from the birth of our solar system. Here, sunlight is faint, and temperatures plunge to hundreds of degrees below zero. Yet, in this silent expanse, secrets have been waiting to be uncovered for billions of years. Once thought to be a random collection of debris, the Kuiper Belt revealed a strange order. Astronomers expected chaos, but instead they found a subtle pattern woven into the orbits of these distant worlds. Astronomers like Mike Brown and Konstantin Batygin noticed a pattern. The most distant Kuiper Belt objects, or KBOs, had orbits clustered in the same direction. This was no ordinary coincidence, it was a cosmic puzzle begging for an answer. Imagine tossing sticks in a pool and finding them all pointing the same way. Something unseen must be influencing them. The universe rarely arranges itself so neatly without a reason. The odds of this alignment happening by chance? Astronomically low. It was as if an invisible hand was guiding these icy bodies, nudging them into place over millions of years. The gravitational pull of known planets couldn't explain it. Jupiter, Saturn, Uranus and Neptune simply weren't enough to account for this mysterious order. The math didn't add up. There had to be another explanation. The equations pointed to a missing piece, a force lurking in the darkness. This was the first major clue, a hidden force, a massive object, shaping the outer solar system. Something enormous was out there, exerting its influence from afar. The orbits of these icy worlds became celestial fingerprints, pointing to a suspect we couldn't see. Each path was a clue, each cluster a whisper of something lurking in the void. The whispers from the Kuiper Belt grew louder. Something big is out there. The evidence was mounting and the mystery deepened with every new discovery. Something massive, distant and powerful enough to change the dynamics of our solar system from the shadows. The game was afoot, and the search for answers had become irresistible. The hunt for Planet 9 had begun, setting astronomers on a quest to uncover one of the greatest secrets of our cosmic neighborhood. What could possibly have enough gravitational muscle to wrangle these distant, icy worlds, keeping them in line at the very edge of our solar system? The answer isn't simple, and it's not just a matter of size or distance. Something powerful is lurking out there, shaping the orbits of objects we can barely see. Only a planet could do this. Not a Pluto-sized dwarf, but a true giant, something 5 to 10 times Earth's mass, a world that would dwarf most of the known planets except the gas giants. Scientists have pieced together a profile, a super-Earth or a mini-Neptune, orbiting on a vast elongated path that takes it far beyond the familiar planets. This is not just a guess, it's a model built from the clues left behind in the orbits of other objects. This orbit would take Planet 9 up to 1,000 times farther from the Sun than Earth, plunging it into the frozen darkness of the outer solar system. A single year on this planet could last up to 20,000 Earth years, making its journey around the Sun almost unimaginably slow. No wonder we haven't seen it yet. It spends most of its time in the deep freeze, far from sunlight, hidden in the blackness where even our best telescopes struggle to see. But the mystery deepens. This planet could also explain another cosmic oddity, the Sun's strange 6-degree tilt compared to the rest of the solar system's plane. For decades, astronomers have wondered why the Sun doesn't line up perfectly with the orbits of its planets. Over billions of years, a massive, distant planet could gently tug at the solar system, slowly creating the tilt we see today. Its gravitational influence, though subtle, would be enough to shift the entire solar system's orientation. Two mysteries: strange orbits and a tilted sun, one possible culprit. The evidence is circumstantial, but it's compelling. The case for Planet 9 is built on gravitational breadcrumbs, subtle pushes and pulls on other objects, tiny deviations in their paths that add up to a bigger story. We haven't seen the planet itself, but we see its fingerprints everywhere. Its effects ripple through the outer solar system, leaving clues for us to follow. It's like searching for a ship at night by watching the waves it leaves behind in the darkness. The ship is invisible, but its presence is undeniable. This is gravitational detective work at its finest, astronomers acting as cosmic sleuths, piecing together a puzzle from the faintest of clues. The math gives us a search area, a most wanted poster for a planet that's eluded every telescope so far, but whose story is written in the stars. The Planet 9 hypothesis stands on the shoulders of history. Neptune was found in 1846 by tracking Uranus's odd orbit. Math led the way. Now, Planet 9 is our modern Neptune hunt, but the stakes are higher and the search area vaster. Its presence is inferred only through its gravitational effects on distant objects. The challenge is immense, but the potential discovery is profound. Critics suggest the clustering could be an illusion, observational bias. To counter this, astronomers conduct massive sky surveys, searching for more KBOs to test the pattern. Each new discovery strengthens the case for a massive perturber. This is science at its core: hypothesis, prediction, verification. Whether Planet 9 is found or not, the search is already revealing more about our cosmic home. The chase itself is a victory for science. How do you find a planet 1,000 times farther from the Sun than Earth? It's a staggering challenge. Planet 9 would be incredibly faint, colder than Pluto, nearly invisible. Astronomers use powerful telescopes like Subaru in Hawaii, scanning huge swaths of sky. The technique takes multiple images over time, searching for a tiny dot that moves against the stars. It's the ultimate cosmic spot the difference. This generates mountains of data, requiring advanced software to sift through and flag candidates. We're teaching computers to be cosmic detectives, recognizing the subtle signature of a slow-moving object. The search is a global effort, combining data from telescopes worldwide. The hunt for Planet 9 is as much about innovation and collaboration as it is about discovery. Current telescopes have built the case for Planet 9, but the smoking gun, a direct image, remains elusive. Enter the next generation, the Vera C. Rubin Observatory in Chile. Its mission scanned the entire southern sky every few nights, creating a time-lapse movie of the universe. With its massive mirror and record-breaking camera, it's the perfect tool to spot a faint, slow-moving object like Planet 9. If Planet 9 is out there, Rubin will almost certainly see it. Other new telescopes like the James Webb Space Telescope and the Giant Magellan will help study it in detail. We're building a new toolkit, and the odds of solving the Planet 9 mystery are better than ever. The future of astronomy is bright, and it's coming soon. The Vera C. Rubin Observatory is a game-changer. For centuries, astronomy was static, snapshots in time. Rubin's legacy survey of space and time will create a dynamic, high-definition movie of the universe. Its primary mission is to tackle big questions like dark matter and dark energy, but it's also perfect for mapping our solar system. It will discover millions of new objects, and somewhere in that data, Planet 9's signature may be hiding. The observatory's sensitivity and ability to detect motion make it our best shot yet. The data will be public, inviting scientists and citizen scientists worldwide to join the hunt. Anyone could spot the telltale movement of a new world. This democratizes discovery, turning astronomy into a global effort. Rubin stands as a beacon of hope in this cosmic detective story. If Planet 9 is real, Rubin will likely find it. If not, we'll know for sure. Either way, our understanding of the cosmos is about to leap forward. The quest for Planet 9 leads to a bigger question. What else is out there? Every new telescope has surprised us. Moons, galaxies, and more. If a world 10 times Earth's mass can hide so long, what else lurks in the Kuiper Belt or beyond? Our solar system may be far more crowded than we think. The Rubin Observatory will likely reveal a new population of worlds, forcing us to redraw our maps. Beyond our solar system, rogue planets may wander the galaxy, untethered to any star. The universe is not a finished book, it's a story still unfolding. The search for Planet 9 is just one chapter in a much grander narrative. Ultimately, the story of Planet 9 is about us, our unquenchable curiosity. It's the same drive that led our ancestors to look up and wonder, to explore, to map the unknown. Science is our tool for asking better questions and finding answers. The hunt for a hidden world is a perfect embodiment of this spirit. We search not for profit or power but because the universe has given us a puzzle. This pursuit connects us to something larger, reminding us we're part of a grand cosmic story. Whether we find Planet 9 soon or never, the journey itself matters. The search has already pushed technology, deepened our understanding, and inspired new generations. The age of discovery is not over. It may have only just begun. The maps of our universe are still largely blank, and we are the cartographers. Let Planet 9 be a symbol of all the mysteries yet to solve. The search continues, fueled by the most powerful force in the universe, human curiosity.